find the angle BAC. So let's draw this first. Okay. What I'm drawing is the base. Okay. So what I'm drawing is the base. I have this base. I have D, A, C, B. Okay, we have this base here. And the angle I want to find is BAC. Okay, the angle I'm trying to find is BAC. So BAC is 45 degrees because there's a square and you put the diagonal on it, and BAC just 45 degrees. But it not looks like 45 degrees in the 3-dimension graph. Okay, 3D graph is not looks like 45 degrees, but when you sketch it base in 2 dimensions, then it will show you clearly that's 45 degrees. And I want to find the length of AC. Okay, the length of AC is, that's 1. AC is square root of 1 square plus 1 square, that is square root 2. Okay, it's the diagonal. Okay, the diagonal, so we'll use Pasag. Okay, we'll use Pasag. And then I want to find the angle of CAG. Okay, I want to find the angle of CAG. So let's again draw that. So I have the A, I have the G here, and I have the C here. Okay, so GC is perpendicular to AC. Okay, GC is perpendicular to AC. Why GC is perpendicular to AC? Because GC is perpendicular to the whole base. Okay, GC is perpendicular to the whole base. And then any line on the base will be perpendicular to GC. Okay, if a line segment is perpendicular to a plane, okay, the plane is BACD, then any line on that plane will be perpendicular to that line segment. Okay, so that line segment is perpendicular to BACD, that plane, and any line on this plane will be perpendicular to that line segment GC. Therefore, GC is perpendicular to AC. We have a right angle here, and CG will be 1. Okay, CG will be 1. Okay, why CG is 1? Because that's a cube, so all will have length of 1. And we just worked out AC. AC has length of root 2. Okay, in part B, we just work out AC. Therefore, I want to work for the angle CAG. Okay, CAG. Let's say I want to find that angle theta here. I want to find that angle theta here. So, question C, I want to work on the value of that theta. So, we first will have tangent theta because we have the opposite and we have the adjacent. So, tangent theta will be 1 over root 2. Okay, 1 over root 2. If we want to rationalize that, that will be root 2 over 2. We times root 2 on both top and bottom. We times root 2 on both top and bottom. So theta will equals to tangent inverse of root 2 over 2. Theta will equals to tangent inverse of root 2 over 2. So we'll correct it to 2 decimal places. Okay, 2 decimal places. Tangent inverse root 2 root 2 over 2. Okay, so check first is in degrees. Okay, it's in degrees. And then control and enter, that gives you 35.26 degrees. Okay, 35.26 degrees. want to know the length of AG. Okay, I want to know the length of AG. So AG is the hypotenuse. So AG equals to square root 2 squared plus 1 squared. Okay, so I want to work on the hypotenuse, a squared plus b squared, and take square root. Do the work. So 2 plus 1 equals to 3. So I have root 3 here. Okay, root 3 here. So if cracked to 2 decimal places, I have remembered that root 2 will be 1.414, so 1.41. And root 3 will be about 1.732, so 1.73. If you can put that into the calculator and calculate on that. But like if you do that a lot, you can remember, okay, root 2, root 3, and root 5. That's 3 values you want to know approximately how large is that. Okay, root 2, root 3, and root 5. I think root 5 is 2.6 something, 2.4 or something. Okay, example 2. Find the angle of elevation this red drinking straw makes with the base of the can, which has diameter of 6 centimeters and height of 11 centimeters. Round to 1 decimal places. Okay, so let's treat this cylinder can is on the horizontal level. Okay, on the horizontal level. The base is horizontal. Okay, the base is horizontal. And I want to know the angle of elevation of this red straw. Okay, so I want to see the angle make with horizontal. Okay, I want to see the angle make with horizontal. So let's pass the diameter. Okay, let's just pass the diameter. Okay, let's say the center is here and draw a diameter here. Okay, draw a diameter here. Okay, connect the point, like the straw touch the base, and connect it with the center and draw a diameter there. Let's give letter A here. Okay, at this point, give A. At this point, give B. At this point, give you C. At that point is O. Don't really need O. Let's say you know that is O. That's enough. Okay, because it's a cylinder, okay, because it's a cylinder, then the height must be straight. Okay, the height must be straight. Then the height will be perpendicular to the base. Okay, can you think about that? Like, you have a cylinder, the height is straight, and then it will be perpendicular to the space. So any line on that base will be perpendicular to the height. Okay, so what you can say is the height is AC. So what you can say is AC is perpendicular to the base. BC is the diameter on the base. So AC must be perpendicular to BC. Okay, AC is perpendicular to the whole plane. Then any line on that plane will be perpendicular to AC.
She's in the middle of the sack, so just push that.
Okay, and we can draw this first. Okay, we have AC, we have BC as the diameter, and we have AB as the hypotenuse. Okay, we have A, B, C. But the most important thing is you know AC is perpendicular to BC. We have diameter of 6 and height of 11. I want to know the angle of elevation. Which angle do you think is angle of elevation? A, B, C, okay, is this angle here, not this angle, okay? This angle is make with perpendiculars, not this angle. It's this angle here, make with horizontal. So this is the angle of elevation. Let's see, the angle is theta here. So what I will have is tangent theta equals to 11/6. Okay, we don't know hypotenuse, then that must be a tangent. So theta equals to tangent inverse of 11/6. Okay, tangent 11/6. Control and enter. 61.39 degrees. 1 decimal places, so 61.4 degrees. 61.4 degrees. So the angle of elevation is 61.4 degrees. You need to answer the question, okay? So if it's application type of question, you need to answer the question. You need to answer that was 1 mark, okay? Your conclusion is 1 mark. Okay, example 3. Viewing point A and B are at horizontal distance from a clock tower of 36 meters and 28 meters respectively. The viewing angle of the clock face at point B is 64 degrees. Find the height of the clock face above the viewing level to 3 decimal places, and find the angle of find the viewing angle to the clock face at point A to 2 decimal places. Okay, the viewing angle is angle of elevation. Okay, so it's angle of elevation here. So let's sketch this graph. Viewing points A and B are at horizontal distance from a clock tower of 36 and 28 meters. Okay, I have 38 meters and 28 meters. And the viewing angle of point B is 64 degrees. Let's sketch this diagram first. Have a think about what the diagram will look like. Okay, I'll give you 1 minute. This because there will be a 3-dimension graph. And think about how you can sketch that. Have a think about how you can sketch that. Okay, I'll sketch mine here and you will think about yours. Okay, let's see if we have the same thing. Okay, let's see if we have. Do you have something like that? Yes? Okay, so that's the clock. Okay, clock tower is here. Okay, so I'm standing like it's a horizontal. Let's say it's a horizontal. I'm just showing 3 dimension. But let's see, something is here. Okay, something is here, and someone is standing like 26 away from it, 36 away from it, and someone standing over there 28 away from it, and we all look at that. Okay, we all look at that. Does that make sense? So you know, like the distance, and because the clock tower is straight and it's perpendicular to the whole base here, and any line connecting on from the bottom of the clock tower to like my feet will be perpendicular to the clock tower. Okay, will be perpendicular to the clock tower. So we have right angles here and here. Let's give D here. And then point A is standing 36 away, and B is standing 28 away, and we all look at that. Okay, we all look at that. And we know the angle of elevation for B is 64. Yeah, do you have questions?
Why can't it look like this? In the same direction.
It's okay to say, like, doesn't really matter. There will be like multiple types of graph you can have. You can have them all on the same horizontal level, like a really straight one, and then the top is here, like this one, or it can be all the same direction. It's all good. Okay, so we'll have something similar to that. And the most important thing is, we know that is 28, that is 64. I can work out the value of CD. Okay, I can work out the value of CD. Okay, that's 64, that's 28, and that's the adjacent, that's the opposite. I can work out the value of CD. So tangent 64 degrees will equals to CD over BD, which is 28. CD equals to 28, tangent 64 degrees. So let's say there's 3 decimals, 57.409. 57.409 meters. Okay, so this is the height of the clock tower above the viewing level. Okay, so we'll have that. For part B, I want to know the angle of elevation at point A. I want to know the theta. So tangent theta will equals to CD. Okay, what is CD? CD is tangent 28 tangent 64 degrees. Okay, that is the CD. So I'll write it down here. So tangent theta will equals to CD over AD, and that equals to 28 tangent 64 degrees over AD, which is 36 degrees. I want to keep using exact values, okay? I don't want to use the rounding value. I want to use the exact value CD. So theta will equals to tangent inverse of 28 tangent 64 degrees over 36. Okay, tangent inverse of 28 times tangent 64, which is the height, okay, which is the height of the clock tower, over AD, which is the adjacent. And let's put that into the calculator. Tangent inverse 28 tangent 64 over 36. Okay, 51.9. Let's see how many decimals. 2 decimals. 57.91 degrees. Okay, the angle of elevation at theta will be 51.91 degrees. Example 4. The triangular faces of a right square-based pyramid are at an angle of 60 degrees to the base. The height of the pyramid is 30 meters. Okay, I have a height of 30 meters. Find the perimeter of the base of the pyramid. Okay, it's a square-based pyramid. If I can know the length of the square, I can know the perimeter easily. Let's have a look. Have a look at this shape first. Let's connect the top and the middle point here. Let's say that point is A, B, and C. Okay, I have A, B, and C. Let's say this length is D and E. Let's say that length is D and E. What do you think the relationship between BC and DE? Parallel and length. How about the length? BC is half of that. It's from the center to the side. So it's half of that. Okay, so BC is half of DE. So if I can know the length of BC, I can know the perimeter of the base. Okay, I can know the perimeter of the base. And let's draw this down here. I have A, B, C. Okay, I have the triangle A, B, C, where AB is perpendicular to BC. Because AB is the height. Okay, the height is perpendicular, not perpendicular, yes, it's perpendicular to the whole base. And BC is one length on the base. Therefore, AB is perpendicular to BC. So, their height is 30 meters, which is here. And I have here is 60 degrees. Okay, ACB is 60 degrees. So, I have 60 degrees here. Okay, will you use sine 60, tangent 60, or cosine 60? Tangent. Okay, I want to know BC. So it's opposite and adjacent. I will use tangent 60 degrees equals to AB over BC. So tangent 60 degrees equals to 30 over BC. So BC times tangent 60 degrees equals to 30, and BC equals to 30 over tangent 60. Over tangent 60 degrees, that equals to 10 root 3. Okay, 10 root 3. So have BC equals to 10 root 3 and correct to 2 decimal places, 1 decimal place. So 17.3. So I work out the value of BC, but it's not finished yet because I want to know the perimeter of the base. So what do you think the perimeter is? So BC times what will equals to perimeter? BC times 8. Okay, I have half of that. Okay, half of DE is BC. So I have 4 sides and I have 8. Okay, 8 of BC. So BC times 8 will be the perimeter. So it's 10 root 3 times 8. So 138.6. 138.6 centimeters. Meters, not centimeters. 138.6 meters is the perimeter of the space. Okay. Okay, next let's lesson, we'll start something really important. Okay, I will start something really important, which is directly connected to year 11 methods. So what we have learned so far for this 11 pages is all revision from year 9 course. Okay, it's all revision from year 9 course. And from next one, we'll start something really important. Okay, we'll start something really important. Okay, the rest of time you can work on some exercise.